Hello everyone, I am Abushai Mansari from Kuchbehar Government Engineering College, and today I want to talk about the pulse code modulation. First of all, we see the block diagram of pulse code modulation. We take a continuous signal as the input of analog input, which is simplified, then sampling the continuous signal of analog signal that will make a discrete signal like this. This discrete signal again we are quantizer, then it will make this type of signal. But what is the difference of this quantizer and sampling? That different that the sampling there the distance between two signal, that's and sampling the quantizer signal, that's and that there have same difference. The quantizer, the difference of this signal, same difference, but the sampling, the difference of two signal is not always same. Then after quantizer, then it will make encoding. The encoding, it will make the 0 and 1. That's mean the digital uh, digital system. The ones point is noted that if high frequency component their analog input, then we should use the low pass filter input before we give the signal to samplers. That's one's points is here that if we take a total samples, then the one's formula is L equal to 2 to the power n. Their number is number of bits. If we take the number of bits equal to 3, then its total number of bits will be 2 to the power 3 equal to its levels are there. Then next point is quantization. What is the quantization? Quantization nothing but it is a like of round of number. One example I take, that's 1.59. It's approximate to 5.2. 5.19, that's an approximate 5.2. Same things of there. Here the signals 0 volt to 3 volt. They have the lowest to highest volt, and the step of this signal is 0, 1, 2, 3. That's the step, and the quantization level Q0, Q1, and Q2. That is the quantization level. Then this quantization level, how to calculate the step? VH has a VH means high voltage, then V low voltage upon Q equal to quantization number. How many quantization? 1, 2, 3. 3 quantization. The level therefore Q equal to 3. Then what is the quantization level? 3 by 3. That is the 1. The distance between two voltage 0 to 1 equal to 1. 2 to 1, 1. That is 3 to 1. 3 to 2. That is 1. The level equal to 7. Then that graph will be made like this type of graph. First graph will take this signal analog continuous signal, then it will make this type of signal, this type signal. Okay. And delta 0 delta 1 is the energy of two wave. That's S and this and this, and this delta 0 delta 0, this and this delta 1 is the energy. Yeah. Okay. Then we come the quantization error. What is the quantization error? Error means that is the first we take the analog signal q x q of t, then x q of t, then next first we take the analog signal x of t, that is the continuous signal, and after we this signal, after that signal we make the sampling or quantization or encoding this signal, get this signal. Difference between get this signal of patenting signal then PDPS signal, this difference is called the quantization error. To minimize or reduce the step signal, how to reduce this error? We are required to reduce the error. Therefore, we increase the step. Number of interval is increases the number of interval. Then bit rate will increases. Then bandwidth also increases. At center, the step means S by 2 equal to Q0. S by 2, that's it. S by 2 equal to Q0. S by 2, that's means Q1, Q2, Q3. That is the steps. Then we come the bandwidth. What is the bandwidth? Bandwidth, before we bandwidth calculation, before we require to quantization level, that is L equal to 2 to the power n we have to know. But n, what is the n? N equal to number of bit. But here capital N is printing mistake, that will be small n. Okay, but it's the reason, that's the reason why we written this small n. Then bit rate of pulse code modulation system, the bit rate formula equal to FM. What is the FM? FM equal to minimum frequency, minimum sampling frequency, and small n number of channel, and capital N equal to the sampling, capital N equal to the number of bits. Okay, and the this expansion, the value will be in the hertz always. If the number of bit will increases, then it will be approximate n plus 1 equal to number, capital of n, number of bits, and n plus 1, small n plus 1, it will be approximate number of channel. Then bit rate formula will be 2. That's mean the one here and one here, the formula will be bit equal to f m, and capital N into small n, if the value will be in the hertz. The bandwidth 1 by 2 into 2 of bits rate, but 2 into fm into n into n, the bandwidth formula will be 2 and 2 will be cancelled, then small n capital N and fm. It is the bandwidth of formula. This formula will be required to calculate the bandwidth. Then next slide will come to signal to quantization ratio. What is the signal to quantization ratio? The quantization, there here we are calculate the noise ratio. Signal to quantization noise ratio. Noise, there have to one system noise ratio mistake, sorry. So, okay, next we calculate the noise ratio. S by n equal to normalized signal power by normalized noise power. That is normalized signal power by noise power is delta square by 12. Okay, then but normalized noise power equal to del square by 12. Number of bit p and quantization level related as q equal to the power 12. That's why let's we assume the input signal n x n of t is linear quantization, and the continuous amplitude range x minimum to x maximum. Therefore x minus of x max plus of x max. Okay, the what is the amplitude? The maximum minus minimum, for therefore it will be 2 x of maximum. Okay, now step will become the, now step size will be, what is the step size? Will be delta equal to 2 max by q. What is the q? Q equal to the quantization level. Therefore 2 max by 2 to the q equal to the 3. Therefore the value will put it q to the power b. Okay, the next slide we calculate that the delta equal to 2x maximum by 2 to the power b. This value put it in the down section, okay, in the denomination. Therefore this normalization signal power we denoted the p. Therefore p by 2x maximum by 2 to the d, there is square, that for the 4x square maximum by 2 to the power 2b 1 by 12. Okay, the calculate value will become the x by n equal to 3p by x square into 2 to the power 2b. Okay, the expression will be denoted that the expression will be noise power ratio increases exponentially. That means it will increase like e to the power x graph. Okay, next slide again we will come. If the x maximum will be 1, then if the assume the input xt equal to normalized, then x maximum will be 1. And if we destination signal power is also normalized less than p less than 1, then it will be expansion will be s by n 10 log 10. It will be its uh, its unit will be in decibel, then less than of 10 log 10 3 into 2b. That's formula will be 4.8 into 6b. Its ratio or its unit will be in decibel. Okay, then s by n equal to 3 into 2 into p, p equal to power. Then ratio, then this quantization ratio will be as s by n into less than 3 into 2, because x maximum equal to 1 and p less than 1. This signal noise ratio is said to be normalized. Okay, that is my presentation. Okay, thank you.